All right, we're going to finish recording the Bridges Unit 3 pre-assessment. If you haven't watched the first part, go ahead and watch the first part. It covers the first page, and this is part 2. So first, on number 6, it says find the sums and differences. So basically all we need to do is either add these or subtract them. So we make sure the decimals are lined up, and they are, so we can drop our decimal. There's 8, 9, and 9 plus 4 is 13. 3, carry my 1, which makes it 139 and 8/10. On the next one, same thing, decimals are lined up, so all I have to do is add. There's 2, carry my 1, 9 plus 1 is 10, plus 3 is 13. 3, carry my 1, 1 plus 4 is 5, 6, 7, and my decimal stays right in line and I drop it down. Okay, next one, this one's subtraction. So I have 1 minus 0, we still have 1. 4 minus 0, I can't do that, I have to borrow from next door and regroup. So now I have 4 from 10, which is 6. Keep my decimal right in line, I drop it, and 4 minus 2 is 2. Next one, same thing, decimals right in line. 3 minus 0 is 3. 9 from 8, I can't do that, I have to borrow from next door. So I have 18 now minus 9, which is 9. And drop my decimal straight down, and 0 minus 0, I still have 0. So 93 hundredths. All right, the next one, it says, the football stadium in our town holds thousands of people. Today is Kids Day, and they're only charging $2.40 admission. Complete the table below and show how much money they'll take in for different numbers of people. So one person, we saw one person was $2.40. So we have 1 to $2.40. So and how we got to 10, if we have 10 people, we would have multiplied this by 10, which means we have to do whatever we do to the bottom, we have to do to the top. So whenever we multiply by 10, we move it over one place value. So instead of $2.40, it would now be $24. Okay, just like the 1, here was my decimal, and I multiplied by 10, I moved it over one place value, which is right here, and added my 0. Okay, so on the next one, here I go, I'm now at $240. So if I move this over one place value again, right, that's the same thing as timesing by 10. So which means I have to times this one by 10 again, or move it over one place value, which then would make it 100. And now here I jump to 1,000. All I did was add a place value, or again, multiply by 10. So you have to do that again, which is 2,400. Okay, and that's it for the table. What happens to the number of zeros in the product as you multiply a number by 10, and then by 10 again, and then by 10 again, and why? Well, we discussed up here, every time we multiply by 10, we're increasing it 10 times greater, which moves it over one place value. So if we multiply by 10, it moves over one place value. We multiply by 10 again, we move it over another place value, and 10 again. So I'm not going to go ahead and write the description, but I think after watching the table, you get the idea. John was looking at the table above. He noticed that when you multiply a number by 10, and then by 10 again, and then by 10 again, the decimal point moves over to the right by one place every time. Explain to John why it works this way. Okay, I'm going to save that for you as well. I think, the table can help you describe that, so make sure that you really explain and even show an example in your answer. Okay, on number 8, 1 kilometer is 1,000 meters, and 1 meter is 100 centimeters. So if I make a little ratio table up here, 1 kilometer is 1,000 meters. Okay, and I'm going to do this over here, just in case we need it, and 1 meter is 100 centimeters. Okay, so how many meters is 34 kilometers? So if I have 34 kilometers, How many meters do I have? Well, from 1, how do I get to 34? I had to multiply it by 34. So whatever I do to the top, I must do to the bottom. Well, if I have 1,000 times 34, I now have 34,000. Okay. So the next one, how many kilometers is 34 meters? Well, this one is going the other way. So now if I have 34 meters, how many kilometers do I have? Well, if you notice, with 1 kilometer, I have 1, 2, 3 zeros or 3 place values in a meter. So if I now have 34 meters, I'm going to have to move it 3 place values the other direction because meters are smaller than kilometers. This one's a little confusing, but basically I would have to move it 1, 2, 3 place values. So I would have 34 thousandths of a kilometer. Because if this is 34, if it's 1 to 1,000, basically it's saying that this is 1 to 1,000th is kind of the opposite. Okay, so 1 meter would be 1,000th of a kilometer. So 34 meters is 34 thousandths of a kilometer. So I make sure I put my answer here. How many centimeters is 5.1 meters? Well, if I have 5.1 meters, here I have 1, which is 100 because I added 1, 2 place values. So now I have 5.1, so I need to add 1, 2 place values or multiply it by 100. So here I would move this 2 place values because this is the same thing as moving 1, 2, or timesing it by 100 in order to get from 5 1/10 to 510. So sorry if that confused you, but if I have 5.1, when I have 1, I have 100. So if I have 5.1, I would have 2 place values greater. So this would be 510. How many meters is 340 centimeters? Well, if I have 340 centimeters, how many meters is that? Well, here when I have 510, I had 5 1/10 or 5 10 hundredths. So I now would have to move this one over 2 place values and I would get 3 4/10 or 3 40 hundredths. Either answer will work because this is 2 place values smaller than a centimeter. So it'd be 3.4. Okay, and that's it for that page. We're now going to move on to the next page. Do a switcheroo. Here I have, choose one division combination below and circle it. Pick the one that seems best for you, not too hard and not too easy. So it's really kind of up to you which one you want to choose. And then you have to write a story problem to match the division combination you circled above. So I'm going to go ahead and just choose the very first one, just because it's first. And I'm going to write a story problem to match. So if I have 156 divided by 12, so I'm going to pretend I have 156. I have 156 pieces of candy. To divide between 12 kids. How many pieces will each kid get? Okay, there's my story problem. All right, use the grid below to model and solve the problem. Show all of your work. If you don't know how to use the grid, but you have some other method, work the problem on a separate piece of paper and attach it. So you don't have to use the grid. I'm going to go ahead and show you how to use the grid, and then you write your answer here. So I have 156 divided by 12, and I'm going to switch and use a pencil just in case I need to erase. So I know that there has to be 156 in here, and it's divided by 12, right? So I need to know how many across. So if I have 156, I'm going to go ahead and color in my 100 here. And then I need 56 more. And I know that this is 10 plus 2. Oops, I'm going to do 10, 11, 12 to get my 12 divided by 12. And here so far I have 10. So I know there's 100, but I have 2 strips here. So if I color this in and this one in, now I have 120 to get me 120, but I need 156 total. So I only have 120. So, and I can't go any farther down here because it's only divided by 12. So if I color in this one and this one, that's 20 more, 10 and 10, give 2 strips, which is 140. And that won't quite work because I still need 156. So I still need 16 more. So if I color in this one, this one, this one, and this one to make myself a perfect rectangle, that adds 4. So now I have 144. So let's keep going. And I do this one. Well, that's 10. So 154. And now I have to color in these 2 to make it my perfect rectangle. So I have an array. And so I add 2 more, and now I have 156. And there was 10 strip and 1, 2, 3 more. So now I know that 156 divided by 12 equals 13. And that's it for the Unit 3 pre-assessment.